Greetings to all. So, today we are supposed to see about this digital logic circuits. So, in the digital logic circuits we have the codes. So, we are having the binary system, and the binary system we have only zeros and ones, and it will be difficult for using for more number of numbers. So, for that we are trying to go for codes. When you try to see as codes, it is going to be a understandable format or a understandable one. So, the binary number we have the zeros and ones to be fixed, but whereas here code we are trying to use it for our understanding purpose. And similar to the binary number systems or the number systems, we have the codes to be made available as weighted codes and non-weighted codes. So, each and every digit, so we have zeros and ones, or in the place we have that, and for that we are trying to give the weight. So, in the weighted codes we have BCD, whereas when you try to go for non-weighted codes we have XS3. This is a example. You are trying to take some understandable version or a equivalent form. It can be either this understandable or an equivalent form. For us, how we are trying to get that equivalent form instead of the long form. So, we are trying to go for this BCD. So, the BCD is going to be binary coded decimal. So, for the humans, we are very comfortable with the decimal numbers 0 to 10 or 0 to 9, and with that decimal numbers we can able to perform all the addition, subtraction or all the mathematical calculation. It is comfortable, whereas the computer systems or the processors are easily understanding this binary form. So, we need to have an understandable format or an equivalent format in which we can able to have the binary to be given as a decimal, such that it will be easy to understand for the humans, and it is going to be adaptable for the computers also or the processors also. So, that is why we are trying to go for this binary coded decimal. So, it is going to be a weighted code. So, we are trying to have the weightage. Excuse me. So, we are trying to have this binary coded decimal. So, for the decimal we are trying to have the digits possible. When you try to go for the decimal, the digits possible are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So, these are the digits that are values that are going to be possible in a decimal number system. So, for this we are trying to find the binary values. So, the binary values, so we are trying to go for this binary coded decimal. So, for this 9, so if you try to take the binary equivalent, for 0 it is going to be 0 0 0, or for the 9 it is going to be 1 0 0 1. So, it requires 4 bits. So, the binary coded decimal is going to be a 4 bits number, or it is going to be available as a 4 bits value. So, we are trying to have this 4 bits value. So, if you try to take any given decimal number, for example, if you are trying to go for a decimal number with 25, a given decimal number is going to be 25. For this, if you are trying to get the BCD, it is going to be for this 2. We are trying to get the binary value. For this 2, we are trying to get the binary value, and that is going to be 0 0 1 0, and for this 5 we are trying to get the binary value, and that is going to be 0 1 0 1. So, this is going to be the BCD equivalent or the BCD representation for the value 25. So, this is 25 and this is our BCD value. So, for the humans we are trying to understand at least from 0 to 9. So, what is the value for this number? So, easily we can able to identify this is 5, this is 2. So, we can able to easily represent in the BCD form, and that is why we are trying to use this an understandable format, a binary coded decimal BCD, right. So, this is a weighted code, because when you try to take this position. So, this position is going to be multiplied by 2 power 0, this is going to be multiplied by, conversion is based on this powers 2 power 0 power 2 power 1. So, when you try to take this, this is going to be 1, this is going to be 2. So, it is going to be 1 into 2 plus 1 into 0. So, this will be 0 and this will be 2. So, the value is going to be 2, and that is why we are trying to get this. So, this is a weighted code. And this is a weighted code based on this 4 bits. So, for each and every number in a decimal, or each and every digit of a decimal value, for this we are trying to get a 4-bit equivalent, and that is going to be your BCD value. And this is sorry and here we are trying to follow the weights. So, for this is 2 power 0, this is 2 power 1, this is 2 power 2, and this is 2 power 3. So, this is going to be 8 4 3 sorry 2 8 4 2 1. So, instead of trying to call it as a BCD code, we can also name this as a 8 4 2 1 code, because this is a weighted code. So, weighted code just telling us a BCD, or we can able to tell with the respective weights 8421 code. So, some disadvantages available in this particular BCD, because after 9, that is this 1001, in the 4 bits combination we can able to have the other numbers. So, we can able to have other numbers, and this combination is going to be having 6 combinations. So, here we are trying to have 6 unused combinations from the 4 bits operation. We are trying to have 6 unused combinations. So, it is a waste of value, or that is not going to be contributing to us. So, for that we are trying to have an rearrangement. Instead of trying to go for 8421 code, we are trying to go for 4221 code. So, if we try to add this, it will be coming to 15, 0 to 15. So, that is why we are trying to have this. Whereas, when you try to add this, we are trying to have, so we are trying to use 0 to 9 and remaining 6, 15 minus 9, 6 is going to be there. So, there are 6 unused combination, whereas here we try to have 4, 2, 2, 1. So, we are trying to have only this 9 combinations, and that is why we are trying to rearrange. So, we are not going to be having any unused combination. So, we are trying to always have the used combination. So, here it is also weighted, but that weight is redistributed. This is called as redistributed weighted code. So, we are trying to have a redistribution of the weights such a way that there will not be any unused combinations. All the combinations are going to be used. So, for example, if you are trying to use here, so 0 will be 0, 1 will be 1, we have this 2 to be available like this, or we can also have this as this combination. This is 8421 code, whereas this is going to be 4221 code. So, we can able to have 2 combinations. That combination is used. That is what we are trying to have. In the 8421 code, 6 combinations are not used. So, we cannot able to work on it. Whereas, in the 4221 code, we try to have the combinations to be used. So, multiple representation is available. So, this is going to be having 2 representations, and similarly for 3 we can able to have this combination, or we can able to have this combination. Both are 3. This is redistributed BCD 4 to 2 1, or we can also have it as 2 4 2 1. Instead of trying to go for this combination, we can also redistribute as 2 4 2 1, in such a way that we do not have any unused combination. We have multiple representations, but there is not going to be any unused combination. So, all the numbers will be made available, we can able to use it, and that is what we have it as BCD. This is a weighted code. Okay. So, in the BCD we try to have this 0 to 9 and all those things. So, we try to go for checking the operations, because we are trying to use the numbers or anything for mathematical operations, or any operations must be done in the processor. So, for that we are trying to go for the addition operation. Addition operation in the codes. So, we are trying to go for, we have seen the BCD code. So, in the BCD code how to add, right. So, let us take an example. So, let us have this 63 to be added with 19. So, question is given in decimal format. So, in the decimal format we have it as 63 and 19. So, we are supposed to add, but not in this decimal format, we are supposed to add it in the BCD format. So, for this we are supposed to get the BCD equivalent, or the binary coded decimal value for this 63. So, 6 is going to be available as 0 1 1 0, this is 6, and for 3 it is going to be 0 0 1 1. So, this is going to be 63, and for 16, so sorry, this is 19. For 19 we have this to be 0 0 0 1, for 9 it is going to be 0 0 0 1, and we are trying to perform the addition. So, when you try to perform the addition, we have this as in binary 1 plus 1 is 0 with a carry 1. So, here it is again 1 plus 1. So, it is going to be 0 with a carry 1, and this is going to be 1, and this is 1, and here it is 1 1 1 0. So, we have this value to be available as 0 1 1 1 1 0 0. And if you try to check here, this is going to be available as and this is going to be available as 82. So, whereas for us it is available like this, because in BCD these are going to be available as a unused combination. So, in the unused combination, so we need to convert it into a usable combination. So, this is an unused combination. So, whenever we try to have an unused combination, we are supposed to add 6 to it. So, this is an unused combination in BCD. So, for this unused combination we are supposed to add 6, and similarly this is an unused combination, and when you only have an unused combination we are supposed to add. If you have a used combination, we easily have that value, whereas when you have an unused combination we are supposed to add 6 to that particular nibble, right. So, we are trying to add this. So, it is going to be we are trying to perform the addition operation. So, 0 and this is 1, and this is 1 plus 1, 0 with a carry 1, this is 1 plus 1, 0 with the carry 1. So, we are trying to have a carry to the next nibble. So, when you try to have a carry in the next nibble, we are supposed to check whether this is available in a used combination or unused combination. This is already available as a used combination. 0 triple 1 is actually available as 7, but we are trying to have a carry. So, for that we do not have any 6 to be added here. Only when that is going to be an unused combination we are supposed to use the 6. This is unused combination 0 to 9, this is the other value. So, this is unused combination. So, we are trying to add a 6. So, there is a carry available here, we are trying to check this particular number, and this is used combination. So, for this used combination we try to get the carry and add this. So, this is carry available. So, this is 1 plus 0 with a carry 1, 1 plus 1 0 with a carry 1, 1 plus 1 0 with a carry 1, and this is going to be 1. So, in BCD or the decimal format, for 8 it is 1 triple 0, and for 2 it is going to be 00 10. So, we can able to get the BCD values. Sorry. So, this work of addition of 6 to a unused combination. So, after getting the answer, we are supposed to check whether it is going to be available as an unused combination or a used combination. So, we cannot be able to just check a single position. So, we are supposed to check with all the 4 bits. So, all the 4 bits we are supposed to check whether it is available in the used combination or unused combination. So, it is going to be a complex work. So, instead of this complex work, we are trying to get an comfortable form. So, this is going to be again BCD, but a comfortable form for the addition, and that is going to be the XS3 code, because at a stage 6 unused combinations are there, and that is why we are trying to check all the 6 combinations whether it is going to be used or not, and based on that we are trying to have the 6 addition or not, right. And then that checking of all those bits, that is going to be a complex one. So, for that we are trying to go an understandable format, and that is going to be the XS3 code. As per the words available, XS3. So, whatever value you have, if you have 6 in BCD, it is going to be 0 1 1 0. In XS3 it is going to be 3 additional. So, for 6, so it is going to be 6 plus 3, so it will be 9. This is what is XS3 code, right. This is your XS3 code, again understandable format, but here this understandable format is a non-weighted code. Each and every digit is not coded or not weighted. Okay. So, it is a non-weighted code XS3. So, let us perform the operation for XS3 addition. This is BCD addition. So, addition using BCD. So, let us check with this particular code XS3 code, understandable format for addition operation. Make the addition to be in a comfortable form. That is why we are trying to go for this XS3. So, for this same number we are trying to go for the XS3. So, if you want this XS3, I need to go for this XS3 representation. So, the XS3 representation for 63. So, for 6 it is going to be 3 additional. So, it is going to be 9. For 3 it is going to be 3 additional. So, 3 plus 3 is 6. So, it is going to be 0, 1, 1, 0. And for 1 it is going to be 1 plus 3 and that is going to be 4. So, 4 is 1, 0, 0. And for 9 it is going to be 9 plus 3 and that will be 12. So, it is going to be 1, 1, 0. This is 12. So, we are supposed to perform the addition. So, when we try to perform the addition, so we try to have this 0, this is 1, this is 0 plus 1, this is 0 plus 1, this is 0, this is 1, 1, 1. So, in BCD we are supposed to check the combination whether it is going to be available as a used combination or an unused combination, but here we are supposed to have the 3. Because in the XS3 we are trying to have additional of 3. So, for 0 it will be 3 and for 9 it will be 12. So, we have a 0, 1, 2. These 3 numbers to be unused at the top side and at the bottom side we have 13, 14 and 15 to be unused. So, we have 3 unused at the top and 3 unused at the bottom. So, for that we are trying to add 3 for the nibbles. Whether it is addition or deletion is going to be based on the value. So, we are supposed to check the addition. So, for this addition we are supposed to concentrate only on the nibble carry. So, we are supposed to perform the addition, sorry, here this is a given word available. So, this value we are trying to have, this is called as nibble carry. This is a nibble and this is going to be a carry from one nibble to the other nibble. So, in XS3 we are supposed to check only this carry alone, we are not supposed to check any other things. Okay. So, when you are trying to have this nibble carry, that is only our concentration, we are not supposed to check all the bits. In BCD addition we are supposed to check all the combination whether it is going to be in our representational form or not in our representational form. So, for that we are supposed to check all the bits and then add 6 or not add 6, but whereas we are going to have the 3 to be done in an additional operation. For this we are supposed to check only this place whether there is a carry from the nibble to the next nibble, right. When there is a carry available, then there must be a addition operation to be done and this is going to be the next nibble. This is going to be the next nibble. So, from here to the next place or this nibble to the next place, this carry or not we are supposed to check. So, when you try to check here, we do not have a carry available here. So, when you try to have no carry available here, for this we are supposed to perform the subtraction operation. So, not just as an addition operation we are supposed to do the subtraction, but instead of checking all the bits and whether we are trying to get it in the form of an representational form or a not representable form. So, we are trying to check the nibble carry and based on that we are just doing the addition or subtraction, right. So, for this nibble we are supposed to perform the addition and for this nibble we are supposed to perform the subtraction. So, this is going to be the addition available here. So, it is going to be 0. So, 0 plus 1, 0 plus 1 is 1, 1 plus 1 is 0 with a carry 1 and this is 1 and this is 0, that is all, this nibble is over. Next we are trying to come to this nibble and for this nibble we are supposed to perform the subtraction option. So, 0 minus 1. So, we cannot able to do, we are trying to carry the carry. So, 1 0 minus 1 is 1. Again here we are trying to take the 1 0. So, 1 0 subtract by 1, it is going to be 1, and this is 0 and this is 1, right. So, here we have the 82 to be the answer. So, in the XS3 form 8 is going to be available as 11 and 2 is going to be available as 5. So, this is 1 0 1 1, this is going to be the 11 and this is 0 1 0 0 1 0 1 is 5. So, 85, sorry 11 and 5. So, whatever we have it is as 82, that is going to be the answer. So, we have the BCD for the understandable format between the humans and the computers. For the decimal is understandable by the humans, binary is going to be understood by the computers or the processors. So, understandable format between the humans and the computers, we try to go for the BCD, whereas in BCD when you try to go for the operation, mathematical operation as addition, we have a problem for checking the answer with for all the bits, whether it is 4 bits as representation. So, for each and every 4 bits we are supposed to check whether it is going to be available in an understandable form or our representable form. So, for that we are supposed to do that checking. So, instead of that we are trying to go for another understandable format, and that is going to be XS3. So, each and every value we are just adding by 3. So, it is not going to be a weighted code, it is going to be a non-weighted code. So, each and every digit we are just adding 3 to it. So, that is going to be the XS3, and when you try to go for the addition using the XS3 operation, we are just concentrating on the nibble carry. So, no other positions we are not checking, only the nibble carry. So, after 4 bits whether there is a carry available or not, that is all, a single checking is enough. The 3 is defaultly available, whereas when you try to take this BCD, the 6 is available or not available. So, here the 6 is available, whereas here it is not available. So, again whether we are trying to import from the memory or not, so again there is going to be a confusion, whereas here the 3 is readily available, there is another operation available, 3 is readily available, whether that addition or subtraction alone we are trying to check with this nibble carry. So, when there is a carry available for that particular nibble we are supposed to add, when there is a carry from one nibble to the other nibble, from where the carry is available in that particular nibble we are supposed to add, and when you do not have a carry from this nibble to the next nibble. So, when you do not have a carry we are supposed to perform the subtraction operation. For every nibble we are supposed to perform the operation. So, for this nibble we have to perform this, for this nibble we have performed this. That is what we are trying to get the values. So, we have seen the codes, and whenever you try to go for the number system or the codes, the number systems is usually used for the addition operation or any mathematical operation, in that the addition is default. So, we have seen the addition operation using the BCD, the binary coded decimal, and the XS3. Each and every value just we are trying to add with 3. This is done as an understandable formats, right, BCD and XS3. So, further we will discuss in the future classes. Thank you.